Dear students, today's topic is EMWP-S-12. The title of the topic is the reflection and transmission coefficients Rn and Tn, and to show that the reflection and reflection coefficient plus the transmission coefficient is equal to unity R1. Obviously these are the electromagnetic waves, reflection coefficient and transmission coefficients. We will be later considering that the medium, both the media reflected and the transmitted, where the waves are reflected, are the optically transparent. mu1 is equal to mu2 is equal to mu naught, that is mu r relative permeability is equal to 1 for optically transparent media, and obviously we consider both media as a non-conducting media. The reflection coefficient Rn is defined as the ratio of the average reflected pointing vector to the average incident pointing vector. Pointing vector, obviously you know that it contains the energy or the power. The absolute values of these energies, the pointing vectors, so our reflection coefficient is equal to S2, S we call the pointing vector average divided by S1 average, so this we call it equation number 1. So where the S1 and S2 are the pointing vectors, are the energies or the power contained in an electromagnetic wave in the form of E cross H. So S1 average pointing vector is given by the absolute value, we take half of the E1 cross H1, and S2 average pointing vector is the absolute value is given as the half of the E2 cross H2 absolute value. S2 is the reflected pointing vector and S1 is the incident, average incident pointing vector. Now the transmission coefficient Tn is defined as the ratio of the average transmitted pointing vector to the average incident pointing vector with absolute values. So let S3 average is equal to 1 by 2 E3 cross H3 absolute value, which is the average reflected pointing vector. In the next page 2, we see that while the S1 is the same which we have previously described as half of the E1 cross H1 absolute value. So the transmission coefficient is given as equal to S3 average divided by S1 average. This is equation number 2. Now let us solve the relation for Rn and Tn one by one. First we take the reflection coefficient Rn. Rn is, as per our definition, S2 to S1, ratio of the S2 to S1 ratio. So putting the values of those S2 and S1 in this equation, we get the 1 by 2 terms are cancelled out, and we are left with the Rn E2 cross H2 divided by E1 cross H1 absolute values. So let's take first the E1 cross H1. Since since E1 field vector, which is incident field vector, is given by I E10 e to the power minus j omega t. At the interface we take that the z is equal to 0. So similarly H1 is equal to j E10 e to the power minus j omega t into epsilon 1 over mu1 square root. So taking the cross product of I cross j will be equal to k, and E1 will be E10 square, the incident amplitude of the incident wave electric field part square, and epsilon 1 over mu1 under the root e to the power minus j omega t, e to the power minus j omega t. All these things are inside the absolute brackets. Since the absolute value of the unit vector is equal to 1, so that will equal to 1. Also, if we take the absolute value of the e to minus j omega t 1 by 1, so we get the e to minus j omega t, which is equal to e which is cosine omega t minus j sine omega t. If you take the absolute value, square these two real and imaginary parts, cosine square omega t plus sine square omega t, take the under root, what we get is equal to 1. This is a unity. So we are left with the E1 cross H1 as absolute value is equal to epsilon 1 over mu1 square root E1 0 square, that is the incident amplitude squared value times the epsilon 1 to ratio to divided by the mu1 square root. This we call it down equation number 4. So similarly for E2 cross H2, we have E2 function defined. The solution of the wave z is equal to 0, which is I unit vector E2 0, E is from minus j omega t, H2 is minus j epsilon 1 over mu1 square root E2 0. So similarly we again take the I cross j, which is equal to again k, and k absolute value is 1. So applying the same procedure as we did before, absolute value of the e raised to minus j omega t for both these will be equal to 1, and we have E2 cross H2 is equal to epsilon 1 over mu1 square root E2 comma square E2 which is reflected amplitude square. So now the putting equation 4 in equation 5, equation 4 and 5 in equation 3, we get the reflection coefficient, and simplifying the things which are cancelled, but we found that it is the ratio of the two amplitudes, the reflected amplitude to the incident amplitude, and the square of these two 2. So reflection coefficient, hence the reflection coefficient can also be defined as the ratio of the squared reflected to the incident amplitude of electromagnetic waves. We can express the reflection coefficient in terms of the refractive indices, as we know that n1 is equal to epsilon 1 over epsilon naught, n2 is equal to epsilon 2 over epsilon naught. So what we have, the E2 0 divided by E1 0 whole square is given as n1 minus n2 divided by n1 plus n2 whole square. So that we have in the previous topic, in the previous topic we have also mentioned that the refractive indices. Now the transmission coefficient Tn is the ratio of the Pointing vector, which is the transmitted Pointing vector, to the incident Pointing vector, average obviously. And with the absolute value, we take the absolute average value is again 1 by 2 E3 cross H3 and 1 by 2 divided by 1 by 2 E1 cross H1. So let us solve. We have done the E1 cross H1 already, so solve for the E3 cross H3. E3 is given by I E30 e to minus j omega t. H3 is j epsilon 2 by mu2 square root times E30 e to minus j omega t. So we have now the putting these values in the E3 cross H3. I cross j is equal to k, and the absolute value of the k is 1. It's in epsilon 2 over mu2 square root E30. Also we have the absolute value of these, the exponent is also equal to 1, so we are left with again E3 cross H3 is epsilon 2 over mu2 E3 0 whole square, equation number 7. Now putting these values of equation 7 and 4, we can get the transmission coefficient as the epsilon 2 over mu2 square root to epsilon 1 over mu2 and E30 to E10 whole square. Further, if we put the mu1 is equal to mu2 for optically transparent medium, both media rather 1 and 2, then what we have the transmission, putting these values and the rearranging, what we get transmission coefficient is equal to n2 over n1 E3 0 divided by E1 0 whole square. So here we can see that n1 is equal to epsilon 1 over epsilon naught, n2 is epsilon 2 over epsilon naught. So n2 to n1 ratio will give you epsilon 2 to epsilon 1. So this term is replaced by n2 to n1. Now since we have both these terms, further we can put E3 0 to E1 0 from our previous topic, the reflection and refraction, which is equal to n1 by n1 plus n2. Transmission coefficient is equal to n2 over n1 into 2n1 by n1 plus n2 whole square, equation number 8. Hence the transmission coefficient is expressed in terms of the ratio of the squared transmitted to reflected amplitudes of the electromagnetic waves. So here what we have, obviously with the multiple of the some factor which is the epsilon 2 to epsilon 1, permittivity is also there, but the main, these are the constant things, so only thing the amplitudes we are dealing with inside the media. So now let's show that the sum of these two coefficients, the reflection coefficient plus transmission coefficient, is equal to 1. We have the reflection coefficient as n1 minus n2 divided by n1 plus n2 whole square. Let's take it as equation number 1, and transmission coefficient as n2 and n1. Obviously you know that these are the reflective indices, n2 or n1 minus n2 whole square, n1 minus n2 divided by n1 plus n2 whole square. So adding these two, Rn plus Tn will give us, by replacing the respective values, n1 minus n2 divided by n1 plus n2 whole square, and similarly the other term. Now here if we open that, the 2 and 1, which will become 4 and 1 square, and 1 and 1, n1 and 1 is cancelled out, 4 and 1 is left over on the numerator, which we have the 4 and 1 and 2. In the denominator we have got n1 plus n2 whole square. So we can take this common. Inside what we have left, that the we have opened this n1 minus n2 whole square, which is n1 square plus n2 square minus 2 n1 n2. This is we have written again, and plus 4 n1 n2. So plus 4 1 n1 n2 minus 2 n1 n2 will give you plus 2 n1 n2. This whole term is nothing but n1 plus n2 whole square, which is cancelled out, and we are left with the 1, and which is the required answer. That is the sum of the reflection coefficient and transmission coefficient is equal to 1. Okay, dear students, we reached to the end of the topic, and inshallah we'll meet again in the next topic with a new topic in the electromagnetic electrodynamics this coursework. Thank you.